Rail transport is a means of conveyance of passengers and goods on wheeled vehicles running on rails, also known as tracks. It is also commonly referred to as train transport, in contrast to road transport, where vehicles run on a prepared flat surface. Rail vehicles are directionally guided by the tracks on which they run. Tracks usually consist of steel rails, installed on ties and ballast, on which the rolling stock, usually fitted with metal wheels, moves. Other variations are also possible, such as slab track, where the rails are fastened to a concrete foundation resting on a prepared subsurface. Rolling stock in railway transport systems generally suffers lower frictional resistance than road vehicles, and the passenger and freight cars can be coupled into longer trains. The operation is carried out by a railway company, providing transport between train stations or freight customer facilities. Power is provided by locomotives which either draw electric power from a railway electrification system or produce their own power, usually by diesel engines. Most tracks are accompanied by a signaling system. Railways are a safe land transport system when compared to other forms of transport. Railway transport is capable of high levels of passenger and cargo utilization and energy efficiency, but is often less flexible and more capital-intensive than road transport when lower traffic levels are considered. The oldest man-hauled railways date back to the 6th century BC, with Periander, one of the 7 sages of Greece, credited with its invention. Rail transport blossomed after the British development of the steam locomotive as a viable source of power in the 18th and 19th centuries. With steam engines one could construct mainline railways, which were a key component of the Industrial Revolution. Also, railways reduced the costs of shipping, and allowed for fewer lost goods, compared with water transport, which faced occasional sinking of ships. The change from canals to railways allowed for national markets, in which prices varied very little from city to city. The invention and development of the railway in Europe was one of the most important technological inventions of the 19th century. In the United States, it is estimated that without rail, GDP would have been lower by 7% in 1890. In the 1880s, electrified trains were introduced, and also the first tramways and rapid transit systems came into being. Starting during the 1940s, the non-electrified railways in most countries had the steam locomotives replaced by diesel-electric locomotives, with the process being almost complete by 2000. During the 1960s, electrified high-speed railway systems were introduced in Japan and later in some other countries. Other forms of guided ground transport outside the traditional railway definitions, such as monorail or a maglev, have been tried but have seen limited use. Following decline after World War II due to competition from cars, rail transport has had a revival in recent decades due to road congestion and rising fuel prices, as well as governments investing in rail as a means of reducing CO2 emissions in the context of concerns about global warming. History. The history of the growth, decline and restoration to use of rail transport can be divided up into several discrete periods defined by the principal means of motive power used. Pre-steam, the earliest evidence of a railway was a 6-kilometer diolkos wagonway, which transported boats across the Corinth Isthmus in Greece during the 6th century BC. Trucks pushed by slaves ran in grooves in limestone, which provided the track element. The diolkos operated for over 600 years. Railways began reappearing in Europe after the Dark Ages. The earliest known record of a railway in Europe from this period is a stained glass window in the Minster of Freiburg im Breisgau in Germany, dating from around 1350. In 1515, Cardinal Matthias Lang wrote a description of the Reiszug, a funicular railway at the Hohensalzburg castle in Austria. The line originally used wooden rails and a hemp haulage rope, and was operated by human or animal power. The line still exists, albeit in updated form, and is one of the oldest railways still to operate. By 1550, narrow-gauge railways with wooden rails were common in mines in Europe. By the early 17th century, wooden wagonways were common in England and Wales for transporting coal from mines to canal wharfs for transshipment to boats. The world's oldest working railway, built in 1758, is the Middleton Railway in Leeds. In 1764, the first gravity railroad in the United States was built in Lewiston, New York. The first permanent tramway was the Lipa Railroad in 1810. The first iron plate railway, made with wrought iron plates on top of wooden rails, came into use in 1768. This allowed a variation of gauge to be used. At first only balloon loops could be used for turning, but later, movable points were taken into use that allowed for switching. For the 1790s, iron edge railways began to appear in Great Britain. In 1803, William Jessop opened the Surrey Iron Railway in South London, arguably the world's first horse-drawn public railway. The invention of the wrought iron rail by John Birkinshaw in 1820 allowed the short, brittle, and often uneven, cast iron rails to be extended to 15 feet lengths. These were succeeded by steel in 1857. Age of steam. The development of the steam engine during the Industrial Revolution in Great Britain, initially for pumping water, spurred ideas for mobile steam locomotives that could haul heavy weights on tracks. James Watt's patented steam engines of 1769 were heavy low-pressure engines which were not suitable for use in locomotives. However, in 1804, using high-pressure steam, Richard Trevithick demonstrated the first locomotive-hauled train at Merthyr Tydfil in South Wales. Accompanied with Andrew Vivian, it ran with mixed success, breaking some of the brittle cast-iron plates. 2 years later, the first passenger horse-drawn railway was opened nearby between Swansea and Mumbles. Earliest British steam railways. In 1811, John Blenkinsop designed the first successful and practical railway locomotive. Iraq Railway worked by a steam locomotive between Middleton Colliery and Leeds on the Middleton Railway. His first locomotive, called Salamanca, was built the following year. In 1825, George Stephenson built the locomotion for the Stockton and Darlington Railway, northeast England, which was the first public steam railway in the world. In 1829, he built the Rocket, which was entered in and won the Rainhill trials. This success led to Stephenson establishing his company as the preeminent builder of steam locomotives for railways in Great Britain and Ireland, the United States, and much of Europe. In 1830, the first intercity route, the Liverpool and Manchester Railway, was opened. The gauge was that used for the early wagonways, which had been adopted for the Stockton and Darlington Railway, with a 1,435 mm width which became known as the International Standard Gauge, still used by about 60% of the world's railways. This spurred the spread of rail transport outside the British Isles. By the early 1850s, Great Britain had over 7,000 miles of railway, a stunning achievement given that only 20 years had elapsed since the opening of the Liverpool and Manchester Railway. Early railroads in the U.S. Railroads were built on a far larger scale than those in continental Europe, both in terms of the distances covered, and also in the loading gauge adopted, which allowed for heavier locomotives and double-deck trains. The railroad era in the United States began in 1830 when Peter Cooper's locomotive Tom Thumb first steamed along 13 miles of Baltimore and Ohio Railroad track. In 1833, the nation's second railroad ran 136 miles from Charleston to Hamburg in South Carolina. Not until the 1850s, though, did railroads offer long-distance service at reasonable rates. A journey from Philadelphia to Charleston involved 8 different gauges, which meant that passengers and freight had to change trains 7 times. Only at places like Bowling Green, Kentucky, were the railroads connected to one another. The Baltimore and Ohio Railroad that opened in 1830 was the first to evolve from a single line to a network in the United States. By 1831, a steam railway connected Albany and Schenectady, New York, a distance of 16 miles, which was covered in 40 minutes. The years between 1850 and 1890 saw phenomenal growth in the U.S. railroad system, which at its peak constituted 1/3 of the world's total mileage. Although the American Civil War placed a temporary halt to major new developments, the conflict did demonstrate the enormous strategic importance of railways at times of war. After the war, major developments include the first elevated railway built in New York in 1867, as well as the symbolically important first transcontinental railroad completed in 1869. Electrification and dieselization experiments with electrical railways were started by Robert Davidson in 1838. He completed a battery-powered carriage capable of 6.4 kilometers per hour. The Gross-Lichterfelde tramway was the first to use electricity fed to the trains en route. When it opened in 1881, overhead wires were taken into use in the Mödling and Hinterbrühl tram in Austria in October 1883. At first, this was taken into use on tramways that, until then, had been horse-drawn tramcars. The first conventional completely electrified railway main line was the 106 km Valtellina line in Italy that was opened on the 4th of September 1902. During the 1890s, many large cities, such as London, Paris and New York City, used the new technology to build rapid transit for urban commuting. In smaller cities, tramways became common and were often the only mode of public transport until the introduction of buses in the 1920s. In North America, interurbans became a common mode to reach suburban areas. At first, all electric railways used direct current, but in 1904, the Stubaital line in Austria opened with alternating current. Steam locomotives require large pools of labor to clean, load, maintain and run. After World War II, dramatically increased labor costs in developed countries made steam an increasingly costly form of motive power. At the same time, the war had forced improvements in internal combustion engine technology that made diesel locomotives cheaper and more powerful. This caused many railway companies to initiate programs to convert all unelectrified sections from steam to diesel locomotion. Following the large-scale construction of motorways after the war, rail transport became less popular for commuting and air transport started taking large market shares from long-haul passenger trains. Most tramways were either replaced by rapid transit buses, while high transshipment costs caused short-haul freight trains to become uncompetitive. The 1973 oil crisis led to a change of mindset, and most tram systems that had survived into the 1970s remain today. At the same time, containerization allowed freight trains to become more competitive and participate in intermodal freight transport. With the 1964 introduction of the Shinkansen high-speed rail in Japan, trains could again have a dominant position on intercity travel. During the 1970s, the introduction of automated rapid transit systems allowed cheaper operation. The 1990s saw an increased focus on accessibility and low-floor trains. Many tramways have been upgraded to light rail, and many cities that closed their old tramways have reopened new light railway systems. Innovations, many benchmarks in equipment and infrastructure led to the growing use of railways. Some innovative features taking place in the 19th and 20th centuries included wood cars replaced with all-steel cars, which provided better safety and maintenance. Iron rails replaced with steel rails, which provided higher speed and capacity with lower weight and cost. Stove-heated cars to steam heating cars, piped from locomotive gas lighting to electric lighting, with use of battery alternator unit beneath the car. Development of air conditioning with additional underbody equipment and ice compartment. Some innovative rolling stock included the lightweight, diesel-powered streamliner, which was a modernistic, aerodynamically styled train with flowing contours. Then came the ultra-lightweight car with internal combustion engine in each train's power car. Others included the dome car, turbine-powered trains, bi-level rolling stock, and the high-tech, high-speed electric trains. Even more, in the first half of the 20th century, infrastructure elements adopted technological changes, including the continuously welded rail that was 1/4 mile long, concrete tie usage, double tracking major lines, intermodal terminal and handling technology, advances in diesel-electric propulsion to include AC traction systems and propulsion braking systems, and just-in-time inventory control. Beyond technology, even management of systems saw improvements with the adoption of environmental impact concerns, heightened concern of employee and public safety, introduction of urban area rail networks and public agencies to manage them, and downsizing of industry employment with greater use of contractors and consultants. Trains. A train is a connected series of rail vehicles that move along the track. Propulsion for the train is provided by a separate locomotive or from individual motors in self-propelled multiple units. Most trains carry a revenue load, although non-revenue cars exist for the railway's own use, such as for maintenance of way purposes. The engine driver controls the locomotive or other power cars, although people movers and some rapid transits are under automatic control. Haulage. Traditionally, trains are pulled using a locomotive. This involves one or more powered vehicles being located at the front of the train, providing sufficient tractive force to haul the weight of the full train. This arrangement remains dominant for freight trains and is often used for passenger trains. A push-pull train has the end passenger car equipped with a driver's cab so that the engine driver can remotely control the locomotive. This allows one of the locomotive-hauled train's drawbacks to be removed, since the locomotive need not be moved to the front of the train each time the train changes direction. A railroad car is a vehicle used for the haulage of either passengers or freight. A multiple unit has powered wheels throughout the whole train. These are used for rapid transit and tram systems, as well as many both short and long-haul passenger trains. A railcar is a single, self-powered car, and may be electrically propelled or powered by a diesel engine. Multiple units have a driver's cab at each end of the unit, and were developed following the ability to build electric motors and engines small enough to fit under the coach. There are only a few freight multiple units, most of which are high-speed post trains. Motive power steam locomotives are locomotives with a steam engine that provides adhesion. Coal, petroleum, or wood is burned in a firebox, boiling water in the boiler to create pressurized steam. The steam travels through the smoke box before leaving via the chimney or smokestack. In the process, it powers a piston that transmits power directly through a connecting rod and a crank pin on the driving wheel or to a crank on a driving axle. Steam locomotives have been phased out in most parts of the world for economical and safety reasons, although many are preserved in working order by heritage railways. Electric locomotives draw power from a stationary source via an overhead wire, a third rail. Some also or instead use of battery. In locomotives that are powered by high-voltage alternating current, a transformer in the locomotive converts the high-voltage, low-current power to low-voltage, high current used in the traction motors that power the wheels. Modern locomotives may use three-phase AC induction motors or direct current motors. Under certain conditions, electric locomotives are the most powerful traction. They are also the cheapest to run and provide less noise and no local air pollution. However, they require high capital investments both for the overhead lines and the supporting infrastructure, as well as the generating station that is needed to produce electricity. Accordingly, electric traction is used on urban systems, lines with high traffic and for high-speed rail. Diesel locomotives use a diesel engine as the prime mover. The energy transmission may be either diesel-electric, diesel-mechanical or diesel-hydraulic, but diesel-electric is dominant. Electro-diesel locomotives are built to run as diesel-electric on unelectrified sections and as electric locomotives on electrified sections. Alternative methods of motive power include magnetic levitation, horse-drawn cable, gravity, pneumatics and gas turbine. Passenger trains. A passenger train travels between stations where passengers may embark and disembark. The oversight of the train is the duty of a guard, train manager, conductor. Passenger trains are part of public transport and often make up the stem of the service, with buses feeding to stations. Passenger trains provide long-distance intercity travel, daily commuter trips, or local urban transit services. They even include a diversity of vehicles, operating speeds, right-of-way requirements, and service frequency. Passenger trains usually can be divided into two operations: intercity railway and intracity transit, whereas as intercity railway involve higher speeds, longer routes, and lower frequency, intracity transit involves lower speeds, shorter routes, and higher frequency. Intercity trains are long-haul trains that operate with few stops between cities. Trains typically have amenities such as a dining car. Some lines also provide overnight services with sleeping cars. Some long-haul trains have been given a specific name. Regional trains are medium-distance trains that connect cities with outlying, surrounding areas, or provide a regional service, making more stops and having lower speeds. Commuter trains serve suburbs of urban areas, providing a daily commuting service. Airport rail links provide quick access from city centers to airports. High-speed rail are special intercity trains that operate at much higher speeds than conventional railways, the limit being regarded at 200 to 320 km per hour. High-speed trains are used mostly for long-haul service, and most systems are in Western Europe and East Asia. The speed record is 574.8 km per hour, set by a modified French TGV. Magnetic levitation trains such as the Shanghai Airport train use underriding magnets which attract themselves upward towards the underside of a guideway, and this line has achieved somewhat higher peak speeds in day-to-day operation than conventional high-speed railways, although only over short distances. Due to the height and speeds, route alignments for high-speed rail tend to have shallower grades and broader curves than conventional railways. The high kinetic energy translates to high horsepower-to-ton ratios. This allows trains to accelerate and maintain higher speeds and negotiate steep grades as momentum builds up and recovered in downgrades. Since lateral forces act on curves, curvatures are designed with the highest possible radius. All these features are dramatically different from freight operations, thus justifying exclusive high-speed rail lines if it is economically feasible. Higher-speed rail services are intercity rail services that have top speeds higher than conventional intercity trains, but the speeds are not as high as those in the high-speed rail services. These services are provided after improvements to the conventional rail infrastructure in order to support trains that can operate safely at higher speeds. High-speed railway, commonly referred to as the high-speed rail, is a kind of operating speed of at least 80% more than in the whole operation process of distance over 200 km per hour. As of 2014, the operating speed of high-speed rail systems in the world are running about all set at 300 km per hour. A few systems have relatively high speed. For high-speed rail, speed can be considered high-speed rail lines after transformation from common railroad. Such high-speed rail maximum speed of approximately 250 km per hour. Construction standards for the ballasted bed high-speed railway was built. Such high-speed rail maximum speed of approximately 320 km per hour. Construction of ballastless track technology standards was built. The China high-speed rail represented such high-speed rail mostly built in high-speed bridge, so-called air railway. Such high-speed rail maximum speed of approximately 400 km per hour. High-speed railway is a high-tech integrated system including 6 aspects. Infrastructure, also including the station construction. High-speed train, electricity and telecommunications, including electrical and contact network, safe and reliable communication, signal, dispatching center console, safety control part, including meteorological conditions monitoring, line monitoring, automatic train control and retrieval, road, vehicle automatic monitoring and response system, maintenance and maintenance section, including the line maintenance, high-speed train maintenance and repair, involving a variety of instrumentation maintenance and repair, and maintenance of equipment and monitoring instruments. The other parts, including passenger safety assessment, high-speed rail perspective study, the new high-speed rail line and the new high-speed train, a high-speed train test, high-speed rail financial, high-speed rail operational data storage and analysis, etc. Rapid transit is an intracity system built in large cities and has the highest capacity of any passenger transport system. It is usually grade separated and commonly built underground or elevated. At street level, smaller trams can be used. Light railies are upgraded trams that have step-free access their own right-of-way and sometimes sections underground. Monorail systems are elevated, medium-capacity systems. A people mover is a driveless, grade-separated train that serves only a few stations as a shuttle. Due to the lack of uniformity of rapid transit systems, route alignment varies, with diverse rights-of-way and geometric characteristics. For instance, the Chicago L trains are designed with extremely short cars to negotiate the sharp curves in the loop. New Jersey's path has similar-sized cars to accommodate curves in the Trans-Hudson tunnels. San Francisco's BART operates large cars on its well-engineered routes. Freight train. A freight train hauls cargo using freight cars specialized for the type of goods. Freight trains are very efficient with economy of scale and high energy efficiency. However, the use can be reduced by lack of flexibility. If there is need of transshipment at both ends of the trip due to lack of tracks to the points of pickup and delivery, authorities often encourage the use of cargo rail transport due to its environmental profile. Container trains have become the dominant type in the U.S. for non-bulk haulage. Containers can easily be transshipped to other modes, such as ships and trucks, using cranes. This has succeeded the boxcar, where the cargo had to be loaded and unloaded into the train manually. The intermodal containerization of cargo has revolutionized the supply chain logistics industry, reducing ship costs significantly. In Europe, the sliding wall wagon has largely superseded the ordinary covered wagons. Other types of cars include refrigerator cars, stock cars for livestock, and auto racks for road vehicles. When rail is combined with road transport, a road trailer will allow trailers to be driven onto the train, allowing for easy transition between road and rail. Bulk handling represents a key advantage for rail transport. Low or even zero transshipment costs combined with energy efficiency and low inventory costs allow trains to handle bulk much cheaper than by road. Typical bulk cargo includes coal, or grains and liquids. Bulk is transported in open-topped cars, hopper cars and tank cars.